have a beam of light reflected off the surface of some unknown liquid. So let's just say that this is the unknown liquid here. Unknown liquid. And the light is examined with a linear polarized filter. It's found that when the central axis of the polarizer, so let's say that this is the vertical here, and when we send the incident light, so let's say that the light is coming down like this, it says when we observe it with a polarized, it's found that the central axis of the polarizer, so let's say that this is the polarizer here, and the central axis of the polarizer is tilted. So let's say that this is the vertical, is tilted from the vertical at 54.3. So that means the axis of this guy here, this is the transmission axis, is tilted, so this angle here is 54.30, and the reflected light is completely passed, provided that the transmission axis is parallel to the plane of the interface, and we need to find the index of refraction of the liquid, so NL is unknown here. Okay, well, from the figure we could see that this light needs to go up like this, and the reflected light is completely passed, so that means we have this to be our polarization angle, which has to equal 54.30. So theta p, angle of polarization, has to equal 5430 degrees, and we know that the incident index of refraction, that of air, is 1, and we need to find an I. Now, I did record a video elaborating and deriving Brewster's angles of refraction, Brewster's angle. If you're interested, or Brewster's law, look up the video to see the discussion. For here, I'm just gonna apply it directly because I already discussed it at some length there. So we know that this is Brewster's angle because the light is polarized. All the reflected ray has its electric field vectors perpendicular to the plane of incidence, and none other than that passes. So then I can use Brewster's law, or Brewster's angle, to say that tan theta p has to equal n of the liquid, that's the transmitted in this case, over n incident, which means this is 1, so that just means n for the liquid has to equal tan theta p, which has to equal tan 54.30. So this would be, if you plug this on the calculator, 1.39. Just to make this clear here, that does it.